You step outside at night, you look up, and something feels wrong in a quiet way. The moon is there, but the darkness around it is not really dark anymore. It is like someone hid a giant flashlight behind the moon and forgot to turn it off. At first you tell yourself, relax, it is probably thin clouds. Or maybe your eyes are tired. Then you notice the glow is perfectly centered on the moon, like a halo that is too neat to be weather. And now you are thinking the same thing everyone else is thinking. What is that? Tonight we are going to answer one very strange question. What if a supernova happened behind the moon? Not behind Earth, not somewhere else in the sky, but right behind the moon from our point of view. Would the moon save you, or would it just make the show look cooler while the danger still sneaks in? Okay, first we need to be clear about what a supernova is, because it is not just a big explosion. A supernova is what happens when a star reaches the end of its life in a violent way. The star runs out of the fuel that keeps it stable. Gravity takes over. The core collapses, then the star blows itself apart. It is one of the most powerful events in the universe. But here is the part that surprises people. A supernova is not like a bomb in space that sends a fire wave across the solar system and knocks buildings over. Space is huge. The real danger for Earth is usually not a shock wave, it is radiation and particles, and what they do to our atmosphere and technology. So keep that in mind, because the moon can block some things, but not everything. Now let us talk about what you would actually see first. If the supernova is exactly behind the moon covers the center of the blast from your point of view. That means you do not see the bright new star right away. The moon is like your thumb blocking the sun. The sun is still there, you are just blocking the direct light. But even with the center blocked, the sky can still change. Light can scatter. The area around the moon can brighten. You might see a pale glow, like a soft ring around the moon's edge. The moon itself might look extra sharp because the background is brighter. People would notice fast. Phones come out. Someone says it is aliens. Someone says it is NASA. Someone says it is the end. Someone else says, guys, it's probably a camera filter. It is never a camera filter. Then the moon moves. The moon is always moving across the sky, and it also moves compared to the background stars. So the perfect alignment does not last forever. Minutes, maybe hours. And the supernova starts to peek out from the moon's edge. And when it does, it can look like a brand new star has appeared right next to the moon. If it is bright enough, it can cast faint shadows at night. Not joking. That can happen with very bright sky objects. If it is farther away, it might just be brighter than anything else in the night sky, like a super bright star that does not twinkle much. How bright it gets depends on distance, and distance is the entire story here. So let us do a quick rules of the universe moment. Light takes time to travel. A light year is the distance light travels in 1 year. It is about 9.46 trillion kilometers, which is about 5.88 trillion miles. Yes, those numbers are ridiculous. The point is, stars are far. Even the nearest star system is over 4 light years away. So if a supernova happens, we are actually seeing an event that already happened in the past. We are just now receiving the light like a delayed message. Now comes the big question. Could a supernova be close enough to hurt us? Yes, in theory. But close in space still means far. Scientists often talk about danger if a supernova happened within a few dozen light years, roughly. Not because Earth would explode, but because the radiation could damage the ozone layer and change the atmosphere. Okay, ozone. This is the part where the supernova stops being a pretty sky show and starts being a real problem. High-energy radiation can break apart molecules in the upper atmosphere. That can reduce ozone. And ozone is one of the reasons the sun does not cook everything on land with ultraviolet light. If ozone drops, more UV gets through. That is bad for your skin, but it is even worse for plants and ocean life, especially tiny plankton near the surface. And if the base of the food chain gets hit, the rest of the chain starts wobbling. So if the supernova is far away, none of this matters. You just get a cosmic light show. If it is close enough, the real danger is not that you get blasted off the planet. It is that Earth becomes a harsher place to live under our own sun. Now you might be thinking, but the moon is in front of it, so we are safe, right? This is where things get tricky. The moon can block direct visible light coming from one exact direction. That is real. If you are on the night side of Earth, facing the moon, and the supernova is lined up behind it, the moon can hide the direct flash for you. For a moment, you are in the moon's shadow. But Earth is round. Only part of Earth can even see the moon at that moment. Also, the moon's shadow is not the size of Earth. It is a narrower region, like what happens during a solar eclipse. During an eclipse, the moon's darkest shadow makes a thin path across Earth, not the whole planet. So even if the alignment is perfect, the moon is not a planet-sized shield. And that is only for direct light in a straight line. A supernova also sends neutrinos, and neutrinos do not care about the moon. They pass through rock like it is air. A flood of neutrinos from a supernova can pass through Earth, through you, through your sandwich, and you would never notice. They are like invisible ghosts. Also, high-energy particles do not always behave like a clean flashlight beam. Some of them get bent and scattered by magnetic fields in space. Some arrive over time. Some spread out. The moon is not an umbrella for that. So yes, the moon can block the view. It can block the straight line in a narrow direction. But it cannot guarantee safety. Now let us take a breath and think about what happens next, because the timeline matters. In the first hours, you mainly get a new bright object in the sky. It can be so bright that astronomy gets weird. The night sky becomes less dark. If it is extremely bright, it can mess with animals that rely on darkness. Nocturnal animals use night patterns to hunt, hide, and move. If nights become brighter for weeks, behavior changes. Over days, the brightness can change. Many supernovae brighten, peak, then slowly fade over weeks or months. It is like a cosmic flare that takes its time, and every night people would look up and say, "It is still there." Like the sky has a new permanent notification. Meanwhile, telescopes and detectors around the world go into overdrive. Observatories would measure the spectrum, the color, the energy. They would try to identify what kind of star exploded. They would search for the leftover core, maybe a neutron star, maybe a black hole. And then there is the other punch, cosmic rays. After a supernova, charged particles can travel through space and reach Earth over time. These can increase radiation risk for astronauts, satellites, and high-altitude flights. If you fly a lot, airlines might reroute some paths closer to the equator, because Earth's magnetic field helps protect us more there than near the poles. Satellites might see more glitches. GPS errors could increase. Some communications could get noisy. It would not be constant chaos, but technology might feel more fragile. Now, is that guaranteed? No. Again, it depends on distance and the type of explosion. And now we get to the scariest version of this story. Because not all supernovae are the same. Some supernovae are connected to something called a gamma ray burst. Think of it like a super powerful beam of energy. Not a gentle glow, a narrow, focused blast. If that beam points at Earth, it can be dangerous even from very far away, because it is concentrated. So what happens if a gamma ray burst happens behind the moon? Do you get lucky? Here is the uncomfortable answer. The moon could protect a small moving stripe of Earth for a short time. Just like during a solar eclipse, the moon's shadow sweeps across Earth. If the beam is perfectly aligned and the moon blocks it, the people inside that narrow shadow path are shielded from the direct beam while the alignment lasts. But the rest of Earth outside that shadow path would still get hit. And the shadow moves quickly. During an eclipse, totality in one spot can last only minutes. So the moon is not a long-term shield. It is a brief cover, a cosmic duck moment. So if you are standing in the right place at the right time, congratulations, you won the worst lottery with the best prize. Everyone else, not so much. Quick pause, because this is the part where your brain says, okay, I need a break. If you like these big space questions explained in a simple way, subscribe. We keep it clear, we keep it honest, and we try not to panic until the math tells us to. Okay, back to the exploding star behind our moon. Now let us talk about the moon itself for a second, because people always ask, would the moon get destroyed? Most of the time, no. If the supernova is far away, the moon just gets extra light. It reflects it and looks dramatic. It does not crack, it does not melt, it does not turn into lava. It is still the moon, just in a very rude spotlight. If the supernova is close enough to be a threat, then the moon also gets hit by radiation and particles. But the moon has no atmosphere to ruin and no ecosystems to harm. It is basically a rock that already lives in a harsh environment. The big concern would be for any humans or equipment on the moon at that time. Without thick protection, radiation is a serious danger. The moon is not a safe place to be during a high radiation event. If you learned something new today, hit like so more people can find this video. If you want more what-if science videos that stay simple and clear, subscribe and turn on notifications, because the next one is going to be even wilder. And comment below with your pick. Would you rather watch a supernova behind the moon, or see one happen close enough to light up the whole night like daytime? Thanks for watching, and I will see you in the next video.